guys, so we are going to cover Module 9, Homework 1 today. This is the slope of a line, and I know you guys know all about slopes, but which is why we're doing the video on it, but we just want to go over a few things just to make sure you're still comfortable with it, you haven't forgotten anything. So how would you, or how can you describe a line? Well, a line has a constant slope. That is what it means. So, for example, a line can look like this, it can look like this, it can be vertical, it can be horizontal. What it cannot have is a curve, because then the slope is changing with the curve. So it has to have a constant slope. So what is the slope of a line? Well, the slope is the steepness or tilt of a line. And again, you guys are really familiar with this. You also know that the symbol for slope is M. So it's not a little s, it's actually a little m. And I don't know why that is, but that's our variable. So the slope can also be called the average rate of change, or the rise over run, or the change over time. A lot of different ways to present this, but this equation right here is one you're going to need to know for the test. And this is how you find slope given 2 points. So you would subtract your y points and divide that by the subtraction of your x points, and that gives you your slope. So for example, this is a positive slope, so I'm just gonna use an example here and say it could be a positive 1/2. I don't know what it actually is. That's just a positive number. So this is me saying that if I want to go from one point to another point on this line, I would go up 1 and I would go right 2. And that's how I would get to my next point, from here to here on a line. I would go up 1 and over 2, and that would get me to my next point. Now for a negative slope, and again, I'm just coming up with an example here. What if I say that it's -3/4? What does that mean? Well, that means if I'm here at a point and I want to go to another point, I may need to go down 3, that's because it's negative, but still right 4. So I may need to go down 3 and right 4 to get to my next point. So notice I go right for both of the denominators, but for the numerators, I go up or down depending on if it's positive or negative. Now this slope is a horizontal line. And for a horizontal line, if you think about it, to go from this point to this point, I don't go up or down, so 0 change horizontally, but I do, or I'm sorry, 0 change vertically, but I do have to go over horizontally some number. And this is going to give me a slope of 0. So all horizontal lines have a slope of 0. This is a vertical line, as you can see here, okay? In this case, you are moving vertically some number, we don't know what, but you're not moving left or right. So you aren't moving or changing x values, so you have a 0 in the denominator, which gives you an undefined slope in that case. Okay, so horizontal line, slope of 0, vertical line, slope of undefined. All right, now what if I give you 2 points and I want you to find the slope through these 2 points? Well, the first thing you're going to do is label them. So this would be point 1, so it's going to be x1, y1. This is point 2, so it's going to be x2, y2. So my slope is going to be, according to this formula, y2, which in this case is 4, minus y1, which in this case is 8, over x2, which in this case is 4, minus x1, which is a -2. Be careful here. Some students lose those signs, but it's minus a -2. So 4 minus 8 is -4. 4 minus a -2 is like 4 plus 2, so this is a 6. And then if I divide top and bottom by 2 and reduce it, I get a slope of negative 2/3. So this is a negative slope. That means my line is going to look like this. It's going to be decreasing. I'm going to have a negative slope for that one. All right, let's look at this next one. I'm going to go right down here instead of over. Okay, for this guy, I happen to notice something a little funny. I happen to notice that both y values are the same value. So that's going to be interesting. It means it's going to be one of these special lines. Okay, so if this is x1 and this is y1, and this is x2 and this is y2, that's how we label them. Then here we go for m. We have y2, which is negative 5, minus y1, which is negative 5. Notice I put that in parentheses. I always put my negative numbers in parentheses so I don't lose the sign. Okay, then I have x2 minus x1. A negative 5 minus a negative 5 is going to be a negative 5 plus 5, which is 0. 2 minus 4 is a negative 2. 0 divided by negative 2 is a slope of 0. Any slope of 0 is a flat horizontal line. So that's what we're looking at there. Okay. All right, let's try the next one over here. We have x1, y1, x2, y2. Here we go for our slope. We're going to have a negative 5 minus a negative 9. Notice I put that in parentheses again. You don't want to lose your negatives. Then I have x2 minus x1. This is going to be a negative 5 plus 9 and a 7 plus 1. This is a positive 1/2 slope. Kind of running off the page a little bit. Okay, so this line is going to look like this. It's going to be increasing because our slope is positive. All right, here we go. If I do x1, y1, x2, y2, I happen to notice my x values are the same in this case. So again, it's going to be one of these special lines. So I do y2 minus y1. Whoops, I don't need to put y1 in parentheses because he's positive. Divided by negative 1 minus a negative 1. That's going to give me negative 8 over 0. And remember, if you have a 0 in the denominator, you are undefined. So our slope here is undefined, which means we have a vertical line. So that's what we're dealing with there. Okay, so remember that little formula so that you can have that for your test. You are going to have to find the slope, okay, of different points on your test. All right, now this says, what is the y-intercept of a line? Well, a y-intercept is the point of a line, the point that crosses the y-axis. And so we represent that with a 0, comma b. That's the point. So it's a 0 because there is no x. You are on the y-axis. And this is the point on the y-axis. We call that a b. And so that's why this formula is slope-intercept form. Y equals mx plus b. M is your slope. B is your y-intercept. Okay, so for this particular equation, it says find the slope and the y-intercept. Well, I can't tell what either one of them are because I'm not in this form. So I need to solve for y. So I'm going to subtract 3x from both sides. I get negative 10y equals negative 3x minus 19. Now notice I can't combine these. These are not like terms. Also notice that I put this first because that's the form. Okay, that's the form. Now I need y by itself, so I'm going to divide every single term by a negative 10. And I get y equals 3/10 x, it's a positive, plus 19/10. Okay, now that is an ugly line, but that is our line, and it's in slope-intercept form. So if it wants the slope, this is my slope. It's 3/10. Notice I did not write 3/10 x. X is not part of your slope, okay? All right, what is my y-intercept? It's 19/10. Now, you could also write comma 0, comma 19/10 as the exact point if you wanted to do it that way. And it really doesn't matter for the test which way that you write it. You just need to pay attention on my math lab and find out how they want that written, if they want the value or if they want the point, okay? All right, so if your equation is missing a variable, if it does not have both y and x, then it's either vertical or horizontal, okay? A vertical or horizontal line. If it's a horizontal line, it's y equals some number. So there's no x variable. Your slope is 0, it crosses the y-axis. If it's a vertical line, x is going to equal some number. There's no y variable. Your slope is undefined and it crosses the x-axis. So these are both very tricky questions. They're trick questions here. It says find the equation of the line with a slope of 0. Well, the only type of line that has a slope of 0 is a horizontal line. And all horizontal lines have an equation of y equals a number. Okay, so what is y going to equal? Well, if it passes through this point, here's your x value, here's your y value. So what is y equal to? 5. There's your equation of the line. So don't make it harder than it is. That's all you have to do. Okay. This one, find the equation of the line with an undefined slope. That's telling you this is a vertical line, which means x equals. What is x going to equal? Go to your point. This is x, this is y. X is 7 in this case. So there's the equation of your line. It's that easy. Okay, so you'll have a test question just like one of those on test 4. All right, last page of this homework. Let's see. Nope, my bad. One more after this. One more. Okay, here we go. Let's try to graph. So remember, we're using slope-intercept form to graph mx plus b. You have to graph your y-intercept first. Then from that point, use your slope to get the other point. Also remember, when graphing, slope is a fraction. Okay, remember that when graphing, your slope is a fraction. All right, so let's do this top one. Here's our form. Are we in y-intercept form? Sure we are. Y is by itself. That means my slope is right here. It's a -3. Now, because I'm graphing, I have to turn that into a fraction, so throw it over 1. My y-intercept is a -2. Make sure you pay attention to that sign. So what I'm looking for is the point 0, -2. That's my y-intercept. So 0, -2, there's my y-intercept. Okay. This is my slope. And I'm going to go down 3 and right 1. That's what I'm going to do from this point, not from the origin. So I'm going to go down 3, and then I'm going to go right 1. And there we go. Down 3, right 1. Perfect. And there's our line. Okay. All right, let's try this next one. I can't graph this because I'm not in y-intercept form. So I'm going to subtract 4x from each side to get y by itself. Don't forget to put that -4x first and watch all your signs. Now I'm going to divide by 2. I get y equals -2x plus 4. Now I'm in slope-intercept form because y is by itself. All right, so here's my y-intercept. It's a 4, which means I'm looking for the point 0, 4. So 0, 4. There's my y-intercept, okay? Here's my slope. My slope is -2, but when I'm graphing, I need a fraction. Now, up here, I noticed that my slope was negative, and that made sense because my line is going down. Here, my slope's also negative. I should see my line going down. So this means I'm going to go down 2 and right 1. So I'm going to go down 2 and right 1. And there is my slope. So remember to graph your y-intercept first, then move on to your slope. Okay? All right, one more page for this section. We're going to talk a little bit about parallel and perpendicular lines. Okay, parallel and perpendicular lines. So what does it mean for two lines to be parallel? It means they have the same slope. That's what parallel lines means. And they never touch. They go on forever, just like this, and they never touch. Or they might be coming down, but they have the same slope, kind of like train tracks. And they just stay exactly the same amount apart, and they never change. Okay, what does it mean for two lines to be perpendicular? Perpendicular means they have a right angle. So it's kind of like the origin, but it's two lines that have a 90-degree angle. They form a 90-degree angle. So what does it mean for their slopes? It means they have the opposite reciprocal slope. Reciprocal. So that's pretty fancy math terms, right? That means opposite sign. So one will be positive, one will be negative, and flipped. That's what's happening to their slope. Opposite sign and flipped. Okay, so all we're going to be doing now is comparing slopes. So here are two equations for a line. They're both in y-intercept form. I know that because y is by itself. Are they parallel, perpendicular, or neither? So to find that out, you are going to compare their slopes. That's what you're going to be doing. So this one has a slope of 5. This one has a slope of 5. They have the same slope. So what kind of line has the same slope? Parallel. These two are parallel lines. That's how we know. Okay, let's look at the next one. All right, these are also in y-intercept form. They're using function notation here to replace the y. Here we go. Here's a slope of -9. Here's a slope of 1/9. So these slopes have opposite signs, and they've been flipped. They've been flipped. Notice this is a -9, kind of like a -9/1. This has a positive, so opposite sign, and it's been flipped. So these are perpendicular. I think I forgot my R in there. Okay, perpendicular. Good gracious. Be glad I'm not your ELA teacher. Perpendicular. Okay, awesome. All right, well, here we go. We want to compare again. Well, we can't yet because we're not in slope-intercept form. We can't tell what slope they have. So you're going to have to change both of these. So in this case, I want my 2y by itself, so I'm going to add 10x to both sides. All I did was add the 10x to both sides. Now I'm going to divide everybody by 2, and I get this. Perfect. So this is this line. I just put it into y-intercept form. Okay, for this line, I'm going to subtract 5x from both sides. I get -y equals -5x plus 3. I can't have a -y, so I'm going to divide everybody by a -1. And I get y equals +5x minus 3. So that's this one. Okay, now I'm in slope-intercept form for both. I check their slopes, They have the same slope. Since it's the same slope, these are parallel. Okay. All right, now we have a different situation. We only have one equation, and it wants us to find the slope of a line that's parallel to this and for a line that's perpendicular to this. So the first thing we need to know is we need the slope of this line. Okay, so I want to get y by itself, so I'm going to subtract 3x. I'm going to get negative 2y equals negative 3x plus 2. I'm going to divide everybody by negative 2. I get y equals 3/2 x minus 1. That goes down to a minus 1. Okay, and notice that we never worried about the y-intercept for any of these. The y-intercept does not play a part in parallel or perpendicular. It doesn't matter. We're only looking at slopes. Okay, so if this is our line, a parallel slope for this line would be the same slope, so 3/2. A perpendicular slope for this line would be the opposite sign, so this is positive, so ours would be negative, and we're going to flip it, so 2/3, negative 2/3. And that is going to give us a parallel slope and a perpendicular slope. And there we have it. Okay. All right. So that kind of sums up the parallel perpendicular situation. And that finishes up Module 9, Homework 1. Okay. Let's look at Module 9, Homework 2. Okay, look at all these forms that we need to talk about here. All right, so we need to make sure that you know slope-intercept form, point slope form, standard form, general form, and function notation. We want to make sure that you're comfortable with all of those. So we already know slope-intercept form. It's going to be y equals mx plus b. So if you are asked to put a line into slope-intercept form, you need two things. You need a slope, and you need a y-intercept, right? What if they give you a slope and an x-intercept? Can you use slope-intercept form? No, because you have to have a y-intercept, so be careful there. All right, what about point slope form? Okay, point slope form looks like this. All right, so in this case, you have a slope and you have a point, okay? Not the y-intercept, just a point. So again, you're gonna need a slope, but now you can have any point, any old point you want, and I'm gonna call that x1, y1, because that's where you would put it into that formula. All right, what if they asked for standard form? Standard form just means that you have your x and your y terms on one side and it equals a constant. That's all. Okay, let's skip down here for just a minute to general form. General form just means that everybody's on one side and you're equaling 0. That's all. Okay, so you can easily go back and forth between these two. Now, these A, B's, and C's that you see here, what in the world are they? They're just constants. They cannot be fractions. You're not allowed to be fractions. If you have a fraction, if so, multiply your tops by the LCD, right? Because we know that'll get rid of a fraction. Okay, and also this first term, this x term, cannot be negative. Well, what if it is? If it is, you can multiply or divide all terms by a -1. And there we go. Okay, the very last thing is function notation. Function notation and slope-intercept form are really the same thing. You're going to put it into slope-intercept form, but then replace your y with function notation, which is just f of x. Notice those are exactly the same. All we did was replace that. Okay, so let's do one little example down here at the bottom. It says, use the slope-intercept form of the linear equation to write the equation of the line with the given slope and the y-intercept. So it wants this form. It gives us the slope, there's our m, and it gives us our b right there. So slope-intercept form would be negative 9x plus 5. And we just wrote it in slope-intercept form. Okay. All right, let's try another one. Okay. Here we go. Find the slope-intercept equation of a line having the given slope and containing the given point. So we have a slope, fantastic, and we have a point. Now it wants slope-intercept form. Is this an intercept? Is this y-intercept? It's not. In order for this to be a y-intercept, this would have to be 0, and it's not. So this is not an intercept. This is just a point. So this is like x1, y1. And if you look back at our equations over there, the only line you can write given a point and a slope is point-slope form. So remember, point-slope form looks like this. Okay, whoops, I went ahead and put it in. Sorry, guys. Point-slope form. Now, that's not the form we want. We want to be in slope-intercept, but this is how we're going to have to start because we don't have a choice. This is all the information that was given. So we're going to do y minus 1 because that's y1. Equals, there's our slope, x minus x1, which is 4. So we were able to write an equation, that's our starting point, given our info, but we're not done because we want slope-intercept form. And slope-intercept form looks like that, right? That's what slope-intercept form looks like. We want y by itself. So first thing we're going to do is distribute our 4. And now we're going to add 1 to each side to get y by itself. And there is our answer. So we had to start with point slope, and then we solved for y. And so now we have it in the correct form. Okay, let's try the next one. It says, find an equation of the line passing through the given points. Oh my gosh. Use function notation to write the equation. Now remember, function notation is just y-intercept form, but we replace the y with f of x. Okay, well, for this form, I need a slope, which I don't have, but I do have 2 points. And if you remember the last section, I can get a slope using that. So I can handle that. What I need, though, is a y-intercept. Are either of these y-intercepts? No, they're not, unfortunately. Your x value would have to be 0 for that to be a y-intercept. So I don't have that. But what I do have is I can get a slope and I have a point. So we're going to use point-slope form and then once again solve for y to put it into function notation. Okay, so I'm going to label these. This is x1, y1. This is x2, y2. And I'm going to find my slope. So I'm going to have 14 minus 5 over negative 4 minus negative 1. This is going to give me 9 over negative 3, which is a slope of negative 3. Okay, so I have a slope. Now I'm going to use a point. You can use any one of those points. It doesn't matter. You will come out with the same answer. Now I'm just going to use this one just because it's first and I already have my point slope labeled. So here we go. I'm going to use point slope form. So I'm going to have y minus y1 equals m parenthesis x minus x1. So what is minus negative 1 going to be? Plus 1. Okay, I don't want to leave it like this. I want this form. So I'm going to distribute again, and I'm going to add 5. So what I'm going to end up with is y equals negative 3x plus 2. Okay, that's what I end up with. Now I'm not done. If I circle this, this is slope-intercept form. I want function notation. The only difference is you're going to replace y with f of x. And there you go. And you're done. Okay? So I think you're starting to see that it's a little tricky, right? You have to actually usually go through point slope, even if that's not what you want, and then turn it into the equation that you want. Okay, let's try another one. Find an equation of the line passing through the point. So we have 2 points, and we want function notation. So this one is actually just like the one we just did. It's just going to be a little extra practice. So I'm going to label these, and I'm going to find a slope. Here's my equation for slope. So y2 minus y1 over x2 minus x1. This is going to give me negative 1 over negative 3, which is a slope of a positive 1/3. Now again, we want function notation, but we don't have a y-intercept. If we did, these x values would be 0. So I'm going to have to use point slope form because I have a point and a slope. Now you could use either point, it doesn't matter. I'm going to choose this one. I always just pick the first one. So y minus a negative 7 is plus 7. Here's my slope. X minus a negative 3 is plus 3. And I'm going to distribute that 1/3. I get 1/3 x. Okay, now normally it's just written with the slope out front and the x next to it. You could write x over 3 if you wanted. This is just how it's normally done. 1/3 times 3 is actually 1. You can put that in your calculator if you want to. I'm going to subtract 7, and I get y equals 1/3 x minus 6. Now this is slope-intercept form because I see y. I want function notation. I'm going to replace it with f of x. And there we go. Okay. All right, let's try a couple more. Okay, one more page of these, and then we're going to talk a little bit more about parallel and perpendicular. Okay. All right, what if all I give you is a graph and I tell you to find the equation of the line that's graphed? All right, well, I know it's kind of hard to see here, but I did give you a couple of points. So I gave you this point and I gave you this point. Because if you look really, really closely, this line doesn't actually go through -6 and it doesn't actually go through +4. So I can't use those. Those aren't actually points on there, okay? And also we want standard form. So what we're looking at is your x term and your y term on one side equaling c. And remember, this one has to be positive and we can't have any fractions. So that's the deal with standard form. Okay, so this point to me looks a whole lot like -3, +2. And this point looks a whole lot like +5, +8. Okay, so we have 2 points again. I'm going to write them over here. Okay, here's x1, y1. Here's x2, y2. Our slope is going to be y2 minus y1 over x2 minus x1. That's going to be a 6/8. And we can reduce it down. I almost said 2/3. I meant to divide 2. And we get 3/4. That's our slope. Okay, now the only other information we have is points. So again, we're going to be using point slope form in order for us to get some type of equation. okay? That's not standard form, but it's the best we can do. So we're going to use a point. I'm just going to use this point, and I'm going to have y minus y1 equals my slope, x minus x1, but minus -3 is +3. There we go. Okay, now we want this form to look like this. So first thing I'm going to do is distribute, and I'm going to get y minus 2 equals 3/4 x plus 9/4. Okay, now I am going to have to add this 2 over here to this, but before I do that, remember I'm not allowed to have fractions in standard form or general form. So I notice that I do here, and I have a denominator of 4. So my LCD is going to be 4. And I'm going to multiply every single top by 4 to get rid of these fractions. This is going to give me 4y minus 8. These 4's are going to cancel, and I'm going to get 3x. These 4's are going to cancel, and I'm going to get 9. And now I eliminated my fractions. Okay? So then I have to get x and y on the same side. Now I could subtract 3x and bring it over here, but remember my x term can't be negative. So since it's fine where it is, I'm going to subtract 4y to the other side. Okay? And I'm going to get -8 equals 3x minus 4y plus 9. And I'm going to subtract my 9 to the other side, and I get -17 equals 3x minus 4y. And then if you want to just, this would be fine. You could leave it just like this, or if you wanted to, you could just switch it around and put it just like that. And there we have standard form. X and y are on one side, and there's a constant on the other, and we're good to go. Okay, what if it wanted general form? If it wanted general form, all you would do would be add your 17 over here and have it equal 0. So there's not a lot of difference between general form and standard form. So general, we would just add 17 and have it equal 0. Okay, this wants us now to write an equation of the line in standard form. Okay, so remember, x or y on one side, constant on the other. Well, remember, for a vertical line, your form is x equals some number. We don't have a y. What is our x going to equal? Well, here's x, here's y. So it equals -1. Here, this wants a horizontal line. Horizontal lines look like this. We're going to have y equals, here's a y. There's our horizontal line. Easy as that. Okay. All right, so now these last few problems that we have, okay, 4 left, and we're done with this one, is we're going to be talking about parallel and perpendicular again. Okay, so let's see what information they give us. They give us an equation of a line through this point. So this is just a plain old point. It is not a y-intercept, and I know that because this would be 0 if it was. So this is x1, y1. And it tells us we want a line that's parallel to this. That means we want the same slope as this. Well, if his slope is 4, then we want our slope to be 4 because we want the same slope. Okay, so we have a point and a slope. Now this wants us to use function notation. So remember, this is where we're going with this. That's how we want to end it. But we can't write it like this right off the bat because we don't have an intercept. So we're going to have to use point slope form again. So we're going to have y minus y1 equals m, parenthesis, x minus x1. We're going to distribute our 4. And we're going to add our 6. and we get 4x plus 2. Now this is slope-intercept form. We want function notation. So we're going to replace y with f of x. And there we go. And now we have function notation. Okay, last page. Okay, last page. 3 problems left. Here we go. All right. It wants us to find an equation of a line through this point. So let's label it x1, y1. And we want to be perpendicular. Remember, this is opposite and flipped from this slope. Now, I can't just say this slope is positive 1 because this does not equal y. It equals 8y. So first thing I have to do is divide everybody by 8. Now we have ourselves a slope we can look at. This slope is 1/8. So what's our perpendicular slope going to be? Well, first of all, it's the opposite sign. So since he's positive, ours is negative. And now we need to flip it. So this is 1/8. Our slope is going to be 8 over 1, or just 8, negative 8. Okay, so we again want function notation. They're really big on that. Now we're going to use point slope form because that's what we have. Y minus a negative 8 is plus 8. Here's our slope, x minus 3. We're going to distribute this negative 8. There we go. And we are going to subtract that 8. And we are going to get there for slope-intercept form. We want function notation. So we write it over with y being replaced by f of x. Okay. All right, this wants us to find the equation of the line in standard form. Okay, so standard form, remember, is x and y on the same side and a constant on the other. We can't have any fractions and we can't have a negative first term. All right, let's see what info they give us. They give us 2 points and that's it. So here's x1, y1. Here's x2, y2. There we go. Okay, well, I need a slope because no matter what equation I use, I have to start with a slope. So y2 minus y1 over x2 minus x1. There we go. Okay, so we have that. This is going to be a negative 1 over a positive 2. There's our slope. Okay, now some of you may notice we have a slope. What is this little gem over here? This is actually a y-intercept. So I could go ahead and throw in M and B and make myself a nice little slope-intercept form if I wanted to. Otherwise, what I can do is go ahead and start point slope form by choosing this point. It's up to you. You're going to get the same answer no matter what you choose, because we do have to rearrange it into this form. Okay, so if I just go the long way and I do y minus negative 8, it's y plus 8, equals negative 1/2 over x minus negative 2, there we go. Y plus 8 equals negative 1/2 x minus 1. If I subtract 8 from both sides, I get y equals negative 1/2 x minus 9. Now look at that. If we had used this m and this y-intercept, we would have already been here. We could have done that right away. And so I just took you through the long way to show you that you're going to get the same answer. You really are, as long as you're paying attention to what you're doing. Okay, but we want standard form. So the first thing we have to do is get rid of this fraction. So I'm going to multiply all my numerators by 2, because that's my LCD. This is going to give me 2y. Those 2 cancel, and I get negative x minus 18. Okay, I want x and y on the same side, so I'm going to add x to the other side, and I get x plus 2y equals negative 18. And I'm done. I can have it equal a negative 18, I just can't have a negative in the front for standard form. And so there we go. And we found it. Okay, very last problem. This is a trick question. Find the equation of the line through 13, 1. So here's x1, here's y1, and perpendicular to y equals negative 9. Well, gosh, how can I be perpendicular to something when I don't know its slope? So I can't take the slope and flip it and change the sign. But you do know the slope to this, because this y equals a number is a horizontal line. And what's the slope for every horizontal line? 0. The perpendicular slope for a horizontal line, let's think about this. Here's our horizontal line. What would make a 90-degree angle with a horizontal line? What line are we looking for? A vertical line. A vertical line. So I can't make it negative because 0 is 0. I can't multiply by positive or negative. But what would be the reciprocal of 0 over 1? Well, it would be 1 over 0. And what is 0 in a denominator? Undefined. That's a vertical line. So what I'm actually looking for is I'm looking for the equation of a vertical line. That's what I'm looking for. And a vertical line equation is x equals a number. And the only x number I see is 13. So that was pretty tricky. You had to use a lot of brain power for that and actually picture this line and what would be perpendicular, which makes it a vertical line, and then that would be your equation. So that, my students, is the end of that video, and then we will be all set to finish this packet.